All right, guys, looks like the quiz is pretty much closed out. I was kind of watching this as we went, and what I figured I would do is just kind of go over a couple of these that some of you guys are struggling a little bit with, just to make sure that we're kind of all on the same page with it. Just like anything else, nomenclature in chemistry just requires a lot of practice, and there's tons and tons of homework out there that I assigned for you guys to play with. But let's just kind of look at a couple of these that I think were causing you guys a little bit of trouble here. So this is one where you actually had to go from a formula to a name here. So I'm just going to put the formula up here, CRBr3. Okay, and just kind of dissect this and see if we can figure out what's going on here. Now, Cr there, you'll recognize is going to be the element chromium. So we're going to just go ahead and write that. Okay, now the other element there is bromine. Okay, but we also know that since this is going to be an ionic compound or a salt, we're going to drop the INE and I'm going to add the IDE to it. So we're going to say chromium bromide, but we're not quite done yet. And the reason for that is because of where chromium lies on the periodic table. So is that a main group element or a transition metal element? Which one, guys?
Transition.
You got it. Beautiful. So it lies kind of in that middle area there, the periodic table. And remember what we know about the transition metal ions is that they can take multiple charges. So in this case, we have to specify in the name what the charge actually is. So I'm going to put some parentheses over here. And I got to deduce it now from going back to the bromide. So I know with the bromide, I've got a total of 3 minus charge because I know that each individual bromide has a 1 minus charge because it's over in group 7A. So if I've only got one chromium there, that tells me the charge on the chromium to balance everything out has to be a 3 plus. So what I'm going to do is I'm going to put a Roman numeral 3 in the parentheses there, and that gets me to the correct name. Okay. So that was one, a few of you guys missed. So I just wanted to make sure everybody was on the same page with that one. And then the other two are kind of very similar. So we'll just pick one of those. Let's see if there was one of them that more people missed. So looks like 17 got that one. 22, we'll do the other one. So this one, it looks like I've got chromium 6 sulfate. So let's go ahead and write that out. So this is an ionic compound, but this kind of has everything in the world going on, right? So it's ionic. And in this case, what are we dealing with? We have to go from a name to a formula. So chromium, I know, is Cr. Okay, so we'll go ahead and put that there. Sulfate, now that's a polyatomic ion, right? So from your table of polyatomic ions, we know that's SO4, and we know what charge that takes. So I'm going to go ahead and put that charge up there. It's 2 minus. All right, but now what about the charge on the chromium? Well, that's given to us in the parentheses there. So that's Roman numeral 6. So my chromium there has to have a 6 plus charge associated with it. So the question now is, to get charge balance, how many sulfates do I need? In other words, I got to get a 6 minus over here on this side to balance out the 6 plus on the chromium ion. So how many sulfates am I going to need?
3.
3. So how do I specify that? Now remember, with a polyatomic like this, if I need more than one of them, I'm going to put the polyatomic over here in parentheses, and then I'm going to put a subscript 3 down there to specify that. Okay. So there's just a couple of them. I just kind of want to make sure that we're getting enough practice on this. And again, if this is something you're struggling with, go back and make sure you're looking at those homeworks, because we got tons and tons and tons of them over there you can practice with. Just like anything else, it just takes a little bit of practice to get this right. All right, so what I want to continue with today is nomenclature and naming, and I think we're going to go ahead and finish it up today. So the topic of your video from last night was naming covalent compounds. Now, again, how do I identify a covalent compound? Well, it's always going to be a non-metal combined with another non-metal. How do I identify non-metals? They're over on the right-hand side of the periodic table. Okay, so What I'm talking about there is something like, and we'll just kind of put an example up here for you, this SF6. Okay, I don't remember if this is one I did in the video last night or not, but this is a decent example and one I just happened to have written down. All right, so if you remember from the video, what we do here is we're going to start out by naming the first element with the element name. Now, I also look to see how many of them I have in the formula. In this case, I only have one. Okay, so I don't need a prefix here. So I'm going to call this sulfur. Be careful, we're not going to call it monosulfur. We're just going to call it sulfur. We never use mono in the first element. And then we have the F6. Now, this is where we use those funny prefixes, right? So does anybody remember what the prefix for 6 is? Off the top of your head?
Hexa.
Hexa, very good. So it's sulfur hexa. And then what we do is we're going to name the other nonmetal, the second one, as if it were an anion, right? So we don't call it fluorine, we call it fluoride. So sulfur hexafluoride is what we would call this thing, okay? Now, here's another one that comes up. We'll just take a look at some options here. I could do Cl2O7. All right, there's another example of one that's a nonmetal combining with another nonmetal to form kind of a funny compound here. And since I have a 2 down in front of the chlorine, I got to use my prefix now. So my prefix for 2 is di, right? So I'm going to call this dichlorine because we always name the first element just as the element. Oh, and then I got 7 oxygens. Anybody remember what the funny prefix for 7 is? That's a one you don't use all that much.
Hepta.
Hepta, you got it. And then we add the oxide to it. Now, here's the thing I just want to mention. In my video, I mentioned something about what happens when we end up with a couple of vowels that get parked together like this. So I would probably call this dichlorine heptoxide, but Chem 101 seems to like to keep the vowels together unless they're 2 of the same vowel. So I think Chem 101 would actually accept this as dichlorine heptaoxide. So it's fine to actually keep those 2 vowels together. When's the time you do drop the vowel? It's when you have, for example, 2 O's together. So think about carbon monoxide. We don't call it carbon monoxide, we call it carbon monoxide. So if you have 2 of the same vowels there together, you drop one of them. If they're different vowels, Chem 101 kind of likes to keep them in there. Okay, so I'm going to call it dichlorine heptaoxide because that's what Chem 101 likes, and that's fine. All right. So then we could go the other way if we wanted to. We could do something like dinitrogen monoxide. If I wanted to go to the formula, okay, what 2 elements are involved? What's nitrogen and oxygen? So I'll just write them down. And then the prefixes tell me exactly what those subscripts have to be, right? So if it's dinitrogen, that tells me I've got 2 nitrogens for every oxygen in the formula. And the monoxide, not monooxide, but monoxide tells me I've got 1 oxygen. So I can just leave it just like that. If you want to put the 1 in after it, that's fine too. But N2O is the appropriate formula there. Okay, so everybody kind of sort of see how to do that. And we'll practice with this in Chem 101 a little bit later here. Now, there's one other type of compound that we have to learn how to name, and that's the hydrate. Now, hydrate is kind of like a fancy ionic compound. So we're kind of going back to ionic compounds here, where we either have a metal and a nonmetal, or a metal and a polyatomic ion here. Now, the deal with a hydrate is that it's going to be an ionic compound with water in its formula. Okay, so you're always going to have some water in there, and it'll be some number of water molecules. Okay, so I'll just put an X there to specify that. So water will actually be part of the crystalline makeup of the ionic compound. So in many cases, if you go to, say, the chemical stock room and you get a chemical reagent bottle that has an ionic compound in it, many of them are going to be hydrates. And what you'll see is that there will be water molecules associated with the formula of the ionic compound. Okay, so a typical one that you might see would be something like this. So we got CaSO4, and we'd show it on the bottle as a hydrate this way. You'd have a dot that comes after the ionic compound formula. And then you'd have, for example, 6 H2Os. So what this tells me is that in the overall formula of this compound, it's your regular ionic compound, calcium sulfate, that has 1 calcium in it and 1 sulfate per formula unit. But then associated with that formula, you have 6 molecules of water in there as well. And we actually treat this as a single compound because the water actually becomes part of the crystalline structure of the ionic compound. So that's why we do it that way. Okay, so how do we name it? Well, the ionic compound part, we name the regular way. So it's just the ionic compound name, just like we always do it. Then I'm going to add to it a prefix that tells me how many waters I've got as part of the formulas. This would be, for example, the mono or the di or the tri. Same prefixes we used when we talked about covalent compounds, even though in this case it's an ionic compound. And then after the prefix, we add hydrate. Okay, so if I wanted to put this one together, okay, how would I name that compound? I actually already gave you the name, but it's what? Calcium sulfate, right? So we write that down first, just like we normally would. And then I need a prefix here. So I got 6 waters. So what prefix am I going to use?
Hexa.
Very good. And then we just add hydrate to that, right? Okay. So that's what I would have there. So let's take one just in the opposite direction. I'll give you a name. Let's see if we can come up with a formula. I'm just going to make one up. I don't know if this is a real thing or not. That should be an H. All right, so there's a name, chromium 3 hydroxide dihydrate. So if we wanted to take that back to a formula, how would I do it? Okay, so basically I have to deal with my ionic compound first, which is the first part of this thing. So I've got chromium and hydroxide. So chromium, you guys know, is elemental symbol Cr. Hydroxide is a polyatomic ion, right? That's OH. I'll go ahead and put the charge up there of 1 minus because hydroxide always has a 1 minus charge. Okay. And then I've got the dihydrate, right? So it's going to be times, that's easy, 2 H2Os, but I got to go back and kind of finish out the formula for the ionic compound. All right. So notice the Roman numeral 3 after the chromium. That tells me the charge on the chromium. And chromium, as we know, is a transition metal ion. Okay, so that means it's going to carry a 3 plus. And if each hydroxide carries a 1 minus, how many hydroxides am I going to need to balance the 3 plus out?
3.
3, good. So to get a 3 minus there, remember I have to take the polyatomic ion, put it in parentheses, and put the 3 downstairs. Okay, so if I wanted to get rid of all those charges and stuff, which you don't have to have in there, basically what I would have is chromium OH taken 3 times 2 H2Os to account for my hydrate. Does that make sense to everybody? Kind of, sort of?
Yep.
Yeah, go ahead. Any questions about that?
Can you like leave the slide up so I can continue copying?
Sure, I'd be happy to leave it up a little. Have you got everything you need me to shift it a little or anything?
All right, I copied it. Thank you, Professor.
Okay, no problem. Not a problem at all. So let's go practice again with a little bit of nomenclature. So I'm going to pass this back to Chem 101 here. And I've got a couple of practice exercises. We'll just kind of do one and then do the other. We got plenty of time today. I'm at home today, which is nice. I can actually have two screens open instead of sitting in a classroom. So what I'm going to do is go backwards in Chem 101 here. And I'm going to go ahead and initiate this next set of practice problems. So this one's naming covalent compounds. So these are the nonmetals and the nonmetals. So it's 8 problems. We have 7 minutes to work it. So let's go ahead and open it up and let you guys practice a little bit. And then we'll swing back around and do some hydrates. And again, if any of these don't make sense, just ask. I think I'll just pop over to Chem 101 here as well. So that way, if anybody wants to see what's on my screen, we can do that. Okay, and we're running in this one, so we can just take a look at those. There they are.
Professor, how do we tell if they need the parentheses with the Roman numerals in it by just looking at it?
When you say the parentheses and Roman numerals, what, like, do you have an example for me?
Like the 1, 2, 3, and 4, like in an equation, if we were to like what elements need those, like what elements have those after them?
In terms of parentheses, did you say?
Yeah.
So usually when I use parentheses, for example, in a formula, the only time I would really ever do that would be if I have a polyatomic ion like nitrate or sulfate or hydroxide or something like that. And if I end up needing more than one of them in the formula, then I would put it in parentheses and use a subscript, because what I'm signifying there is that I want to take the whole polyatomic ion formula and then essentially multiply it by that number of things, if it's 2 or 3 or whatever. That's when you would do it.
All right. Thank you.
Like, for example, in these ones, there are no polyatomics here, so you don't have to worry about that in these covalent ones.
All right. Thank you very much.
Sure, no problem. Looks like you guys are doing fine with these. You'll probably see some examples of that in the next practice we do of what you asked about. We'll let this one run out and then we'll go ahead and put the next one up. Got about 2 minutes left in case anybody still wants to have a little more time on it. As you guys finish it up, are there any questions about this exercise or any clarification you guys need here?
I have a question about the hydrates actually.
Yeah, go ahead. We'll get to that next, but yeah, go ahead and ask it if you want.
So the water molecules, they only will bond to ionic compounds and never the covalent compounds.
Yeah, I've never seen a hydrate show up in the case of a covalent species. I'm not saying it couldn't exist in the case of something covalent that's more crystalline, but I can't think of any situation off the top of my head where I've actually seen that I can recall. So I think in our world, it's always going to be something ionic coupled with the water molecules.
Okay.
Not saying it'll never happen. It's just that I can't think of a situation where it does.
After the time runs out, can you go over how to write the chemical formula for diarsenic trioxide?
Sure, I'd be glad to do that. So the diarsenic trioxide one. Yeah, we'll pop back over to my notes and we'll do that. Gladly. Yeah, let me pop out of Chem 101 and go back to notes here. Let's see, it was diarsenic trioxide, right?
Yes.
Okay, we want to go from a name to a formula. Okay, does anybody remember what the symbol for arsenic is? Chemical symbol.
AS.
AS, good. Watch out, it's not AR, that's argon. So arsenic is AS. Oxide obviously is O. Okay, so we have the prefixes here. We got a di and we got a tri. Okay, so if I have a di there, how many arsenics do I need in the formula?
2.
2, very good. And if I have a tri in front of the oxygen, how many oxides do I need to have?
3.
3. So AS2O3 would be your formula. That makes sense?
Yes, I just used the wrong element.
Yeah, no problem. Yeah, that's something you gotta have to watch out for. And that's okay. That periodic table I gave you guys, it actually has the element names on them. So if you end up using that periodic table, you can always check yourselves. All right, let's open up that next one here. So that's the hydrates one, which I think you guys will find a little bit more interesting here. And let's start it. Yep, there we go. So we have about 10 minutes on this one. I'll kind of watch it as we go. And I'm going to just keep my notes open here. So if somebody has a question, we can go ahead and just write it out here on the notes.
So on the first question, the
Yes,
first
sir.
part of the equation would be calcium dibromide, right?
Be careful. You got an ionic compound there, right?
Yeah.
All right, so if we're naming just an ionic compound by itself, just the CABR together, and just
Yeah.
forget about the hydrate for a minute, do we actually use the dye there?
No.
We only use the dye when we talk about covalent, right?
Yeah.
So what would you call that? It would be calcium.
Calcium
What?
bromide.
You got it.
And
Perfect.
then how do you put? Do you know how you put the other half of it in?
Sure.
How do you put the
So
other?
then how do we name a hydrate? So it's going to be something hydrate, right? So then we do use the prefix to specify how many of the waters you need. So you'd have a hexahydrate after that. Okay, so you have to think about this in two parts, right? So the first part is just naming the formula of the ionic compound, just like you normally would. So you forget about the prefixes, right? So you name it, there it is, calcium bromide. Then in the second part, you can bring the prefix back because you have to specify how many of the waters you've got there. So you use the hexa as your prefix there. So think about it as almost two parts if you want. And that's the formula you're going to use for all of these. So name the ionic part first, forget about the prefixes. Then once you have that, then bring the prefixes back to specify how many waters you've got in the hydrate.
For the next one, is that sulfate or sulfide? The
Good
SO4?
question. SO4 2 minus, that's a sulfate, right? Now, if you had a sulfide,
Okay.
that would just be an S2 minus with the IDE ending, right?
Okay. Thank you.
No problem.
Iron phosphate. What? For number 3.
Yep,
So it's iron phosphate. It'll be phosphate, right? Or phosphide.
correct. Yeah, you're using your phosphate.
All right.
Now, here's the trick. You got to know what the charge on a phosphate is, right?
Yeah.
And that'll let you deduce what the charge on the iron has to be, right?
I'm assuming it's like 2.
Well, take a look in your table if you're not sure. So the phosphate is always, anybody know what the charge off the top of your head on a phosphate ion is? Or if you have your table handy?
3 minus.
3 minus. Okay, so what is the charge on the iron got to be?
3.
3 plus. Very good. So what are you going to call it?
Tri-iron? No.
Not the tri, right? 'Cause we're dealing
Iron.
with a iron with the
The
3 in
three,
the parentheses, right?
Okay.
And then the phosphate. Good. And then you can do the hydrate part separately.
Would you put the 3 before or after? Because I still have it wrong.
In terms of the iron, yeah, it comes in parentheses after the iron name. We'll actually do that one. So I'll just write it out.
So that's not iron phosphate tetraoxide?
Well, you're almost there. Missing one thing. Okay. So phosphate, just kind of working backwards, is a 3- charge on the polyatomic. So we said the iron has to carry a 3+, right? So
you
the
also do
one
number
part we
2
were
as well, please?
missing was this. We have to specify, since iron is a transition metal ion, what the charge on it is, because it could be an iron 2 or some other charge, right? So in this case, it's an iron 3, and I can deduce it from the charge on the phosphate. So that's why I got to put it in parentheses to show that. Now, there's the name of the ionic compound by itself. Now we can do the hydrate part. So 4 is tetra, right? And then we just add hydrate.
Could you also do I just have a quick question on number 4. So
Sure. Let me pop up there.
it doesn't have, this is magnesium sulfate,
Yep, got it. Yep.
and it, so the SO4, isn't that are those charges even with the SO4 and the magnesium, since the SO4 is -2?
You got it. Yep. The SO4 is a 2-,
Okay.
and the magnesium is going to be a 2+. Now, here's my question back to you. Do I need to write that as a magnesium with 2 in parentheses after it?
No, because it cancels out. That's what I was going to ask. Yeah.
Right. And it's not because it cancels out, but it's because magnesium is a main group element. It's not a transition metal. So it always carries a 2+ charge. So I don't have to specify that. So don't forget, you got 2 different kinds of metals. You got main group metals and you got transition metals. And if you have a transition metal, you got to specify the charge as part of the name. If you got a main group metal, you don't do that.
Can you do number 5?
Sure can. Let's do that one. So I want, it looks like it's SrOH taken twice times 7 H2Os, right? All right, we got to name that, don't we? So Sr, what's that element name?
Strontium.
Strontium. Now, if you find strontium in the periodic table, right, it's over in group 2, isn't it? Group 2A. So is it a transition metal or a main group metal?
I think transition.
Not a transition. It needs to be over 1 to be a transition metal. Okay, so it's over in the first 2 columns, right? So if it's in the first 2 columns, it's a main group metal. So do I need to specify the charge on it? Anybody
No.
remember my main group?
Yes.
Actually, I don't. I know it's a strontium 2+, right? And I can put that up above there because where it is in the periodic table tells me that. And I can verify my formula here. I've got a 1- per hydroxide, but I have 2 of them. So there's my 2-. But because of where strontium is in the periodic table, it's not a transition metal. So I don't actually have to specify the charge. I don't specify the charge. So I'm just going to call that strontium hydroxide. And maybe it would be good for us to go back and look at a periodic table again and just sort of go back over that. And then how many waters do I have? It looks like 7. So what's my prefix for 7?
Hepta.
Hepta, good. And then we just add the hydrate there. Okay. So that would be the correct name for that one. Any other of those that you guys would like to go over?
Can you hear me?
Sure.
Can we go over number 6?
Sure. So let me write down what we got there. So that looks like it's barium hydroxide octahydrate. That's another good one. And we're going the other way this time, right? Octahydrate. Okay, so barium is what symbol?
BA.
BA, good. Now notice in the name, it doesn't have a parentheses with a charge after it. What does that tell you about barium? Oh yeah, that's a main group element. I know that's true because it's over in group 2A. Okay. Now hydroxide, that's OH1-, isn't it? I'll go ahead and put my 1- up there because I like to remember what it is. So we can go back to the barium and look at its position in the periodic table. It's over in the second column. So that tells me it has to lose 2 electrons to look like its nearest noble gas. So barium's always going to have a 2+ charge. So now I see that I have to have how many hydroxides to balance out the barium charge-wise?
2.
2, very good. So I put that down as a subscript. Now somebody asked me this earlier, when do I use the parentheses, right? Well, this is a perfect example of when you use the parentheses around a polyatomic because I need to take 2 of them. And the 2 here represents that I need 2 of the hydroxides. If I wrote this, for example, like this, what would that tell me? That's different, isn't it? That tells me that it's 1 barium coupled with an oxygen and 2 hydrogens, and that's not the same thing as what I wrote above. Okay, everybody see that difference? So that would be not how we write it. And then octahydrate. Octa says 8, like the octopus has 8 arms or legs, and the hydrate is H2O. That makes sense?
Yeah, thank you.
Perfect. And let me just, in the last minute or 2 of class, I just want to go back to the periodic table real quick and just show one. I think I have one over here somewhere. I think it's over in my files. I just got to find my files. There it is. There it is. It's popped right up. Okay. And I don't, maybe I can actually write on this thing. I'm going to try. All right. So it says I can write and I'm not able to do it. That first column there, yeah, it's not gonna let me write on this thing. Doggone it. I'd like to be able to do that. But anyway, look at the first column there where the hydrogen is. Okay, that's gonna be column 1A. Look over to beryllium. That's gonna be 2A. Okay, so those are my main group elements. Remember the pink ones in the middle there? Those are the transition metals. Those are the transition metals. Okay. So I should, yeah, it's going to let me write. Okay, so that's going to be, it doesn't let me write up there. These guys are my transition metals. And anything to the left or the right are my main group elements, okay? So these guys up here are main group. All right. And that's where most of the nonmetals are. And it actually turns out it doesn't show this. And I think it does show on your periodic table. There's kind of a zigzag that kind of works through here like this. I'm going to just sort of show it. Like that. Can you sort of see that zigzag I put in there? And that's how I delineate between the metals and the nonmetals. Anything to the right of that zigzag turns out to be nonmetals. Things like carbon, nitrogen, oxygen, sulfur, bromine, iodine. Those are all nonmetals. Anything to the left of that zigzag is considered to be a metal. Okay, so notice how my main group metals can either be over here to my left. It'll let me write it here. Okay, so groups 1A and 2A are your main group metals. Transition metals are in the middle, and then the main groups follow over to the right. So the blues and the greens are all main group, and the pinks are the transition metals. So hopefully that'll help you kind of clarify kind of where things are in the periodic table, so you can specify whether you need to use that Roman numeral or not in the in there. Any questions about that real quick, guys? I just wanted to make sure you guys were okay with that.
Is
And
this
feel-
exact table on D2L?
I actually haven't stuck that in there. The table that I gave you guys, I think I put a table up in D2L. That's the one that has the names and everything in it. If you want to mark that up so you can keep all this straight, feel free to do that.
Okay. Also, just for clarification, so covalent nonmetals get prefixes, transition metals get Roman numerals,
Yes.
and then that's it.
And your main group doesn't get either of the above. Yes, you got it. You're there. You're there.
Can you repeat that again, please? I'm sorry.
She did it better than I could. Can you repeat that for me?
Sure. Covalent nonmetals get prefixes. Transition metals get Roman numerals, like in the equation, and then main groups get nothing.
You got it. Perfect.
And you said I have the main group gets nothing, covalent non-metals get the prefixes, and what's the other group? The transition metals get
Roman
They
numerals.
get they get the Roman numerals in the parentheses.
All right, thank you very much.
No problem. That'll help you kind of sort this out and get used to it. All right, just one other reminder, guys. You got a Friday quiz coming up, so
I need that.
look
I need
back
that one more
over
time.
that.
Can I have that
Covalent-
one more time? Sorry, thank you. Go ahead.
No,
She's on it.
Covalent nonmetals get prefixes. Transition metals get Roman numerals, like in the equations, and they're in the middle of the table. And then the main group gets nothing.
Thank you.
Yeah, that's about as succinct as you can possibly be and get it. Perfect. So remember, Friday quiz, guys. Look back over everything from the past week, and that's what I'll basically write my quiz based on. All right, and next time, make sure you watch the next video. That one's on the mole concept, so you might get a really, really, really easy mole concept problem on the Friday quiz. So make sure you watch the video. All right, guys, I'll see you on Friday.
Thank you.
Thank you.
Indeed. Thank you, guys.
Thank you.